The paper of the day is Presto, SQL on Everything. This paper presents Presto, an open-source distributed SQL query engine developed at Facebook. Presto is designed to be adaptive, flexible, and extensible, supporting a wide range of analytics workload, from sub-second latency reporting to multi-hour ETL jobs across diverse data sources. The paper details Presto's architecture, key design decisions, performance optimizations, and real-world use case at Facebook, demonstrating how a single SQL engine can unify analytics over heterogeneous data systems. Here are the key contributions. The first, unified SQL analytics. Presto provides a single ANSI SQL interfaces to query data across Hadoop, RDBMS, NoSQL, and streaming systems, reducing the need for multiple analytics engines. Second is extensible connector API. Its plugin-based architecture allows high-performance integration with dozens of data sources, making it highly adaptable to new storage systems. Third is high performance and scalability. Presto supports hundreds of concurrent queries and scales to thousands of nodes, efficiently utilizing cluster resources for both interactive and batch workloads. Then we have resource management. Fine-grained integrated resource management enables multi-tenancy and high cluster utilization. Then we have industry adoption. Beyond Facebook, Presto is used by Uber, Netflix, Airbnb, Bloomberg, LinkedIn, and powers Amazon Athena. In terms of highlights, here are the key ones. The first is federated query across data sources. To quote from the paper, its extensible federated design allows administrators to set up clusters that can process data from many different data sources, even within a single query. This reduces the complexity of integrating multiple systems. The second is adaptive resource management. Presto's integrated fine-grained resource management system allows it to quickly move CPU and memory resources between queries to maximize resource efficiency in multi-tenant clusters. The third is performance optimizations. Code generations for JVM bytecode, adaptive scheduling, and in-memory shuffles over HTTP enable both low latency and high throughput workloads. Presto is capable of returning results even before all the data is processed. Intermediate data and state is stored in-memory wherever possible. When shuffling data between nodes, buffering is tuned for minimal latency. Here are some of the interesting diagrams from the paper. The first is the Presto's architecture. It shows the coordinator and the worker nodes, with the coordinator handling query planning and orchestration and workers executing tasks and fetching data from external systems. As you can see, you have the query, it goes to a queue, then there's a planner and optimizer, then there's a scheduler. Planner and optimizer talks to the metadata API, scheduler talks to the data location API, then both of the data location API services and metadata API services, they talk to external storage system. Then the workers also talk to them. We have data source API, and each worker will have its own processor which will process, and the worker will there'll be a unified worker which will connect all these results, and then it will show it to the user. Here's the second diagram. It's the logical plan that illustrates how a SQL query is broken into logical operations, that is aggregate, join, filter, scan. So you can see from the diagram, first there is a scan from two tables, orders and line item, then there is a filter, then there is a left join, and then there is an aggregate. In this case, it's sum. And finally, we have the distributed and optimized plans. Here we visualize how Presto partitions queries into stages and pipelines and how intra-node parallelism is achieved. So here's the distributed plan for figure 2. The connector has not exposed any data layout properties, and shuffle reduction optimizations have not been applied. 4 shuffles are required to execute the query. That was mentioned in figure 2. So we have the scan, then filter, then hash join, and then after the hash join, there's a partition shuffle, there's an aggregate finder, and then we show the output as stage 0. Here are the notable quotes from the paper. Presto processes hundreds of petabytes of data and quadrillions of rows per day at Facebook. Presto allows organizations like Facebook to deploy a single SQL system to deal with multiple common analytical use cases and easily query multiple storage systems while also scaling up to 1,000 nodes. Adaptiveness over configurability. As a complex multi-tenant query engine, Presto must be adaptive not only to different query characteristics, but also combination of characteristics. In terms of paper score, this gets 9.5 out of 10. The paper is exceptionally clear, comprehensive, and practical. It not only describes the technical architecture and optimizations of Presto, but also grounds them in real-world use cases and operational lessons. The extensibility, performance, and industry impact are well demonstrated. The only minor deduction is for the lack of deep discussion on fault tolerance, which the authors acknowledge as an area of future work.